Hi, welcome to Nomis Academy. This time we'll be dealing with length of an arc. Yes, recall that there is what we call circumference. Circumference, I said, is the total length of the line that makes a circle. So the total length of this line that makes a circle is circumference. Now, when we talk about an arc, arc is a part of circumference. Arc is a part of circumference. When you look around, you see that this is a circumference. Now, this part, little part, is an arc. Any part of circumference cut out of circumference is an arc. So how do we then know the length of part of a circumference cut out? Yes, there is a formula to calculate length of an arc. Length of an arc is given by the angle subtended by a sector cutting out that arc from the circumference of a circle multiplied by the circumference of the circle. This is what I'm talking about. Length of an arc is equal to 2 pi r open bracket theta all over 360. So out of 360 degree, a particular arc is cut out in an angle that should be calculated. So that angle in 360 multiplied by the circumference, that is the total length of the circle, is the length of the arc. I said, I repeat that again, length of an arc is equal to the total length of the circle, which is the circumference, multiplied by the part of the circumference that is cut out by a sector in respect to the angle of the sector. So theta represents the angle of the sector that cut out part of the circumference, which we call an arc, from the 360 degree. So that's how to calculate an arc, the length of an arc. So let's look at this. So take this angle to be 60 degree. So we have the radius 21 centimeter. So the angle at the center of the circle is 60 degree. So how do we get to know the length of the chord from here? I mean the length of the arc from here to this part. That is what we need now. So the length of the arc from here to here, or the other parts. So let us get to know. The formula has been given. The length of an arc is equal to 2 pi r. So where r is the radius of the circle, and you know pi to be 22/7, and you know theta to be the angle subtended by the sector cutting out an arc out of the circumference of the circle. So let us put in the formula. So let us put in the parameters of the formulas. Length of the arc is equal to 2/1 multiplied by 22/7 multiplied by 21/1 multiplied by theta is 60 divided by 360. So 0 cancels 0, 6 here 1, 6 here 6, 7 here 1, 7 here 3. So I'm left with 22 times 22 multiplied by 3 multiplied by 1 all over 6. So I can further to say 3 here 1, 3 here 2, 3 here 1. So 2 here 1, 2 here 1. So I'm left with 1 times 22. times 1, that is 22. 1 is left at denominator, so 22 over 1. So our answer here is 22 centimeters. So the length of this arc is 22 centimeters. So if I want to calculate the length of the bigger arc, then I can calculate the area of I can calculate the circumference of the circle and subtract the length of an arc, then I'll get the length of the other arc. Or I still take the same formula to calculate it when theta becomes 300, because 16 is subtracted away from it, so I can get the bigger part. So let's quickly do that roughly. So roughly the length of the larger arc or the major arc or the bigger arc, so we will still take the same formula to calculate it, that says that 2 over 1 multiplied by 22 over 7 multiplied by the radius is still 21 multiplied by this time it will be 300 over 360. So we have 7 here 1, 7 here 3. So we have 2 over 1 multiplied by 22 over 1 multiplied by 3 over 1 multiplied by, this will be 5 over 6. 5 over 6, correct. So I can say 3 here 1, 3 here 2, so that 2 here 1, 2 in 2 is 1. So I'll be left with 22 times 5. So 22 times 5 is 110. 110 centimeter. So that tells that the larger arc, that is from here to this part, is 110 centimeter. If I calculate the circumference of the circle, it must surely give me 132 centimeter, because the larger arc plus the smaller arc should give me the circumference of the circle. Let us confirm to know that this is like that. Let's calculate the circumference of the circle. Recall that circumference of a circle, circumference of a circle is 2 pi r. So that is 2 over 1 multiplied by 22 over 7 multiplied by the radius is 21 centimeter. So 7 here 1, 7 here 3. So I'm left with 2 times 2 is 44 multiplied by 3. So 44 multiplied by 3, 132 centimeter. So can you see the total length of the circumference? Can you see that the major arc plus the minor arc would give us 132 centimeter. So let's take another example on length of an arc. Example number 2. An arc. The question says find the length of the arc. Find the length of the arc which subtends an angle of 45 degrees at the center of a circle. At the center of a circle of radius 12 centimeter. Radius 12 centimeter. So this question is a JAMB pass question. That was 2012 pass question mathematics. So just as we did the first question. It's as simple as firstly introducing the formula that says that length of an arc is equal to circumference multiplied by theta all over 360. So the circumference 2 over 1 multiplied by 22 over 7 multiplied by the radius here is 12 centimeter over 1 multiplied by theta is 45 over 360. So if I begin to divide, I will have, I can say 2 here 1, 2 here 18 0. So I can say 9 here 5, 9 here 2 0. So I can say 5 here 1 and 5 here 4. So let's write that down first. So we are left with 1 over 1 as 1. So 22 over 7 multiplied by 12 over 1 multiplied by 1 over 4. So I can further divide it by saying 4 here 1, 4 here 3. So I'm left with 2 times 3 is 66 divided by 7. So 66 divided by 7, 66 divided by 7. I know definitely 7 times 10 is 70. That means 7 times 9 is 63. So I have 9. So point, I'm left with 3. That's 30. So that's 4 in 28. It will remain 2 0. So 2 0, that will be 2. Remainder 6. So let's say that's 2. So remainder 6. 60. So 70 is 60. That will be 8. So I can approximate to 2 decimal place by saying 9.43 to 2 decimal place. So this is the length of the arc, 9.43 to 2 decimal place. So I hope you understood this length of an arc. If you have any question, drop it in the comment section below. Bye bye. See you in the next video.